what do you mean by, or what do you understand by a mixed method, and what are its advantages? Have someone used mixed method so far in their work? Yeah. And then if you think like it's much more powerful or useful than quantitative or qualitative analysis, any thought on this? Basically, I'm putting here very basic general definition, yeah, because one can also go a bit deeper and then define that in a very concrete way, yeah. Basically, mixed method is mixing two methods. No? It's mixed and then methods. Now, what sort of method we are mixing here is like quantitative and qualitative research methods, and why we are doing is we want to draw the strength from two different methods. Like last time, we talked a bit on limitation of quantitative approaches. Also, we talk a bit on limitation of qualitative approaches. Yeah, and then the mixed method strategically integrates or combines quantitative and qualitative methods to draw on strength of each other. Now, so it's more like mixing of two methods. So how can we mix two methods? Yeah, there are three general ways to mix these methods. Now, the first one is that we can use a quantitative method and qualitative method in parallel to talk to address or to explore the same research question, and then we can compare or relate like the findings. So whether we are getting the similar finding or different findings, and then we go for interpretation. What does that mean? And then we can also use qualitative method first and then go for quantitative method for further analysis, or quantitative method first and then qualitative method for further analysis. Yeah, so in terms of sequence, we can also change either of the sequence of this method and then apply that. This is more like a general way. Yeah, and to address some questions, we may need to use both quantitative and qualitative analysis, and then it could be used in any of those sequence. So do you know, or have you known, or have you used any analysis applying these basic mixed methods? No? So do you know, like when you talk about this, like when you have some sort of like a, let's say, overview of these three different types of mixed method, do you recall any of those studies that use this sort of mixed methods? So is there any example of like parallel design? Yeah, so mainly like using both qualitative and quantitative approach together. So does anyone know such a study? Not like using quantitative and then doing qualitative analysis and then qualitative analysis and quantitative analysis, but comparing qualitative and quantitative analysis. Yeah. So what I like is like about this parallel design is one of the example is this impact of climate change. So I pick a random publication here. So this is one of the public publication which says that comparing climate change perception and meteorological data in rural West Africa to improve the understanding of household decision to migrate. So what is done here is like they are looking at perception of the person, like how what the people think in terms of increase in temperature or decrease in temperature or changing let's say precipitation patterns. And there are a lot of studies like this are done in terms of like what people perceive in terms of climate change. But at the meantime, there is also a lot of data, meteorological data that is available, and then we can also compare how similar or different perception comes from the people, because normally in terms of people's memory, it says that people remember, let's say, only, let's say that this winter is a very harsh winter. So normally people remember the recent event more than the last events that was happening many years ago. So and this is really interesting to compare such thing, because here it's quite interesting. So the first is here, the first rate, not rate, but you see this two rows, and then four columns, yeah? And then here, like, four columns are different sides, yeah, and then two rows are, the first one is a perception of the people, and then the second row is observation, yeah? And the color red means decrease, color green is increase, and then yellow is stable, and mainly with plus and minus is like slightly changes. And we can see that when you talk about annual rainfall, most of the stakeholders or households think that there is a decrease in total rainfall. But when we look at the statistical data set or meteorological observation, yeah, we see that in some location it's increased, or it's significantly increased, or even like a slightly increase. Yeah? So we see that mainly for rainfall, yeah. And in some cases, like in terms of dry spell, they call it like it's also rainfall, and the dry spell is quite opposite. Yeah? It's quite related. When there is no rainfall, it will be dry spell. Yeah? And then we can see that even though the people say it increased in terms of data, we see like only or the Euro researcher says only a slightly increase of these events. Now, so this is really an interesting thing to see, like how there are difference between what is measured, yeah, and what people perceive. Now, and we can see here, like in terms of let's say temperature, we see that there is a good match, because people also think there is an increase, yeah, and then also the data shows that there is an increase in temperature. And we can also see similar phenomena when we compare, let's say, database in terms of SDG synergies and trade-off and what people perceive. Normally, people may, like even expert may think like there is a positive linkages between all the SDGs, but due to certain strategies, there might also be negative linkages. Now, so one of the method is to compare perception with data. And whenever, if you are doing some sort of like a perception-based analysis, and if you have a data, especially in terms of this climate thing or the climate change, I would encourage to look at also this data set, because sometimes things could matches, but there are also things where things could varies a lot. Second approach is to use quantitative data, yeah, to analyze the quantitative data and then combine it with the qualitative data for further analysis or further interpretation. Yeah. So one of the example here would be this approach here. Now, so where what is done here is like we started here with STG interaction studies, mainly quantitative studies and interaction studies using correlation. Yeah. So last week we discussed a bit about correlation analysis to understand STG interactions. And what correlation analysis cannot tell is that whether it's a causal relation or not. And here the idea is to build a system model. And what we did here is like in this step, like identify directional connection of extracted pairs. What we did here is like we looked at the SDG target interactions, and then based on the quantitative information, what we did is that we try to go for more like a qualitative information here, yeah. And here how we want to do, or how we did, is that we look at we extracted, let's say here, the positive correlation, yeah, and we put that in here in an Excel sheet, and then ask experts saying that, for example, here, build resilience to environment, economic, and social disaster, we see a positive correlation with reduce the adverse effect of natural disaster, yeah, and ask like whether it would be a direction, which direction it will go, yeah, it will go from like reduce the adverse effect of natural disaster, will have a positive impact on let's say 11.1, will it have a positive impact on 1.5, or it is other way around, or they will not see any direct connection, because causal correlation doesn't mean causal analysis, and there might be other factor that is behind this. And this is how this is one of the examples that could be used, like we based on quantitative analysis and then extract the result, yeah, and then for further processing we can do some sort of like a qualitative analysis. Here the qualitative analysis is expert perception, yeah, or expert opinion. Here other would be like one can also go deeper into the literature and extract the information from the literature to identify why the mechanism behind those interlinkages. The second sequence is to do qualitative data collection, yeah, and then further use this quantitative data collection to do this qualitative analysis. So during the discussion of we already discussed a bit about this different approaches that is used, starting from collecting stakeholder perceptions, stakeholders or focal group discussion to develop the scenarios, yeah, and then use that scenarios in models, yeah, and then to do some qualitative analysis further on. Here is an example on SDGs, yeah, and here what colleagues did was that they looked at impact of SDGs, yeah. This is the example for Sweden, yeah, how SDGs interact. And here in the row and in the column, these are more like SDG interactions, SDG targets. So that's why the number is like 1.3, 1.5, yeah. And based on the SDG interaction, based on the stakeholder expert consultation, what they did here is that they look at whether there will be like a positive or the negative impact, yeah. And last week we also discussed about the 7 scale SDG interaction classification, yeah. +3 means like highly positive and -3 means like highly negative associations, yeah? And they use this and then they fill this matrix, yeah, based on the stakeholder consultation, yeah. And this is more like a qualitative information they obtained it from the stakeholders, yeah. And then what they did is like they went a step further and then build SDG network out of this. So this could be another approach, like you can collect the qualitative information based on literature, based on stakeholders, based on focal group discussion, based on questionnaire survey or semi-structured interviews. And then in terms of SDG interactions, you can let's say you can think about developing a matrix like this, SDG interactions matrix, and then further on you can understand what is the SDG interlinkages, doing some sort of like a quantitative analysis here, more like a network analysis to see which are mostly connected SDG target, and this sort of network analysis will provide information on like what are different what are the targets that need to be prioritized, yeah. And here what a step further is taken, yeah. And here based on this network characteristics, yeah, here the colleagues identify or categorize these targets into 4 clusters, and one can also use the information that is coming from qualitative analysis to do some sort of like a cluster analysis in the next step. So does anyone know what is cluster analysis? Have someone done the cluster analysis? Have you done a cluster analysis? In a simple way, the cluster analysis, we are doing a cluster analysis already here in the class, because there is a class of students which belongs to AIT. There is a class of students that belongs to Kathmandu University. There are 2 clusters of students in this classroom. Yeah, this is one way. Yeah, and we can also make a cluster or class in another way. There is a group of students that are physically present in the class. There is one cluster. Yeah, there is also another cluster of students which are more online. Yeah, so that's another class. So cluster analysis is but this is quite simplistic way to do that. But we can also look at cluster, not only, let's say, divide a cluster, not only taking into account this one or two parameter, we can also take into account many parameters, like, let's say, how can we look at the cluster depending upon your age, your gender, yeah, your country background, yeah, your education level. And then if you look at all these different parameters, and then things becoming more complex, and then one need to do a bit of, let's say, a bit of more rigorous analysis, yeah, a bit of more mathematics behind that, and then do some cluster there. So the cluster analysis is to group certain, let's say, certain features, yeah, based on their number of, like, based on their features, and then try to figure out, put similar things together. And here the feature could be multidimensional, so it may have different dimensions. So you can, if you are interested, you can also look further on cluster analysis. Now, one of the famous cluster analysis is to use k-mean analysis. And then we talk slightly about multi-criteria analysis. So another approach is also to use a multi-criteria analysis. Like, multi-criteria describe any structured approach used to determine overall preference among alternative options, where the options accomplish several objectives. So this is more like a very general definition here, and I would say that if you make multiple criteria to make any decision, that's a type of multi-criteria decisions. And here this is like Ellen et al. Also propose a multi-criteria analysis for SDG, for in terms of SDG prioritization, yeah, in terms of SDG implementation, looking at, let's say, here starting from the scoping, and then assessing the baseline, assessing the interlinkages, assessing the alignment. Alignment here is mainly like alignment of SDGs with existing policy and plan, yeah, and then evaluating or prioritize and evaluate, and then develop a plan, and it could be more in a circle, yeah. And this is how a country could let's say a country could prioritize their SDGs. So there are also this multi-criteria analysis, and one is proposed here by Ellen et al. Mainly on how one can look at use this multi-criteria analysis for prioritizing SDGs. Why it is needed. So why one need to understand this interlinkages between SDGs and bioeconomy, yeah, and then looking at interlinkages mainly based on starting from correlation analysis, and then moving forward to causal analysis, and then also developing a network of SDGs, network of interlinkages between SDGs and bioeconomy, and then also analyzing the policies, yeah, here the European SDG, European bioeconomy strategy, and here what we are doing is, like, we are looking at a policy document or national bioeconomy strategy, and try to map that how SDG targets are mentioned there, and then combining these two things. So we are evolving, or we are moving forward from let's say we are looking at these interlinkages, and then try to do some sort of like identify interventions to cluster, or to I would say, like, interventions that need to be promote sustainable bioeconomy strategy for achieving sustainable development goals. So far we discussed a bit in detail about mixed methods. Yeah, we discussed a bit on how mixed method could be applied in a different way. So now, if you don't have question, I think I do have a question. Yeah, so if you want to do, let's say, SDG interlinkages analysis for SDG 7 using mixed method, how will you do that? Yeah, so definitely, like, you can, if you are doing some of your research maybe later on you will find either you will be using quantitative approach, you will be using either qualitative approach, and there might be a case that you might be combining these two. And here the intention is to give you there are different methods available, yeah, and it's up to you to go a bit deeper on those methods and try to see what fits more. Yeah, what is a model? What do you understand by a model? Model is more like a, let's say, representation or simplified representation of some complex issues. Yeah, but also in terms of like a, let's say, in the fashion industry, what is a model is what a model try to do is to try to sell certain types of accessories or clothes or accessories or if you talk about role model, he or she is a role model because people want to be like him or her. And then there is also this complex questions or complex systems that could be represented in a simplistic way. And one of the famous quote here is like, all models are wrong, but some are useful. So we have to think that all model is just it's not real. It's a model because it's not real, but it's more like a representation of reality. Yeah, but that's why it's not perfect in a way that it can show all the real phenomena. But some of the model, if they are used in a wise way, it is helpful because it's useful. So yeah, so there are different types of models. So you already mentioned some of them. Yeah, I don't want to talk or go through all the models or different types of model, but I would like to pinpoint few. One would be this conceptual model here. So here in this let's say tree circular model. So this is a model that is used in this project called the world towards 2050. I would talk about this a bit in a while as well. But here basically the idea is that there is biosphere, yeah, so which we can also call let's say in terms of this bullseye economy model, so more like ecological limits or environmental limits or planetary boundaries. And then we can see society. Yeah, so there is this three layer, like economy is a heart there because people do economic activities for generating societal well-being, and then whatever we need to do with nature. Yeah, and then we need to do within the limits of nature. Yeah, and this is one of the model which provide this three interlinkages of socio-economic and environmental aspect with different colors, and then how they interact with each other. So the developer of this model called it as a wedding cake model, but I hate this term wedding cake, yeah, because you know why? So like people call this model also like a wedding cake model. And do you know why it is called wedding cake model? Yeah, because more it's in a Western culture when they are wedding, when there is thing, yeah, they want to have this layer of cakes. And then one of my criticism here is like in every wedding there is no cakes. So it's more like a Western centric thing. And but overall concept about these three layers and interactions are quite nice here. Yeah, so it goes in the direction of like a 3D representation of this bullseye economy model. And there is also this other model, like other conceptual model, which try to categorize SDGs into like, let's say, essential needs, governance, and objective. This is coming from Buji Fu from Chinese Academy of Science. Yeah, and then he provided this conceptual model about SDGs, and then try to see like how SDGs are interlinkages. Mainly saying that okay, there is a need to create essential need. Yeah, and then there should be also some sort of like a governance need to be there. So as we see that there are a lot of conceptual models there, yeah, or conceptual frameworks. In one of your work later on, you may need to develop some conceptual framework, conceptual model for follow up or for advancing your study there now, or use as a foundation for your study. Second, here I would like to highlight SDG systems model. Yeah, here I call it SDG systems model because we are looking at SDG as a whole. This slide was also presented before. Basically, here we develop our SDG system model using this iModeler software. Here is a link. Yeah, if you have time later on, you can also click on the link and then play with this model. Yeah, and basically the principle here is that the overall goal of the 2030 agenda is to transform into a sustainable world. Yeah, whatever that means. Yeah, a sustainable world. And for achieving a sustainable world, all the SDGs equally contributes. Yeah? And since there are many targets within a SDG, each target contribute for achieving achieving particular SDGs. Yeah, and then here we call it SDG system model because we look at contribution of all those targets for having a sustainable world as a system as a whole. Yeah, and then what we did here is like we also included this SDG interaction part. Like there is no there is not only direct influence of one goal to other target, there could be also indirect influences like because of this positive or negative linkages between two SDGs. Now, for example, here SDG target 1.1 could have positive influence on target 2.1. Yeah, so that's why due to this positive influence, target 1.1 could have more role on achieving a sustainable world when we look at the system as a whole. Yeah? So this is one of the example of SDG system model looking at system as a whole. There is also mathematical models, yeah, and mathematical models could be a simple expression. Have you heard about this model, predator-prey model? Have someone heard about this term, predator-prey model before? In terms of models, there are also, let's say, mathematical models here. Yeah? And then this is one of the mathematical models, which is mainly based on differential equations. Yeah, and this is one of the initial models that one need to study when someone is doing, let's say, ecological modeling. Yeah? And basically, depending upon the parameter, if there is a lot of predator and a small amount of prey, what will happen is that because of let's say a lot of predator will eat all the prey, yeah, and then it will go hungry and then the population will collapse. Yeah? We can see such thing, let's say, in terms of like overgrazing of the pasture land. Yeah, and maybe because of overgrazing at some point there might be a huge number of cattle could be fed on in the pasture. Yeah, but after some point when there is no pasture left, the cattle population will decline, yeah, or collapse. Yeah? So this is also the case if we think about, let's say, a lot of prey is there. When there is a lot of prey, then and not enough predator, the prey population may increase, but at some point there is a lack of resources. Yeah, and due to lack of resources, the prey population would also decline. Yeah? And this is an example of, like, depending upon the parameter setting, we can get this fluctuation of this predator and prey across time. Yeah, and on a long time the population could be maintained. Yeah, and this is one of the model that could be used. Yeah, so other mathematical model could be like based on statistical analysis. One can, let's say, plot, for example, how GDP is linked with energy consumption. Yeah, so one can also use this statistical graph as a model and try to predict or try to use this model to make prediction on how much energy will be needed in future based on projection of GDPs. Yeah? So these are also different models, different or very simplistic models that are used in science by different communities. Yeah? And there could be also a combination of these sort of like a differential equations or statistical equations, yeah, to develop more complex model here. This is one example, this integrated sustainable development goal model, or ISDG model. Yeah, so this is a model that is developed by Millennium Institute. Yeah, which has also a long history of such a system dynamic model now, and then they try to tailor or advance further their existing system dynamic model to SDGs. Yeah. And here one can look at, let's say, different relation between different SDG targets at the indicator level, and try to make some sort of like a prediction depending upon the strategies. Yeah? So if you are interested more on this ISDG model, you can also look at this demonstration video. Yeah, and then you have also some reports for certain countries. Yeah? So you can also look a bit closer on those country specific examples. So there is also another set of model called integrated assessment model, yeah, or integrating modeling, which is a type of scientific model that try to link different features of socio-economic system with biosphere, atmosphere, yeah, with more like natural system, like linking natural earth system with human system in an integrated way. And that's called that is why it's called integrated assessment models. Yeah? So there are several of these integrated assessment models that are run by different working group, across the globe. Yeah, have you heard about integrated assessment model before in other contexts? So here, like I took this slide from one of the presentation I got online, and it says like, what is an integrated assessment model? So it has human system, it has natural system, and then there is some interactions going on into human system and natural system. Here, the energy is provided quite prominently because this is more like driven by energy community. Yeah. So integrated assessment models integrate representation of multiple human and natural earth system. Yeah. And then like because of this integrated nature, yeah, it can provide a bit more closer insight on co-evolution of different co-evolution on human and natural system. Yeah. Across different scenarios. Yeah. So one can look at different scenarios and then use this model to do some sort of like a scenario exploration, try to understand what may happen in the future if we go from one way to other way. Now, RCPs, representative concentration pathways, which is more about how Earth system may look like in different warming conditions. Yeah, and then there is also this SSP scenarios, which is shared socioeconomic pathways. It's more about scenario for socioeconomic systems. Yeah, and combining these SSPs, RCPs, yeah, one can also look closer at what happens if the human population use different types of energies, if there is a different types of food demand and so on. And this is what this different integrated assessment models can do or are doing. Yeah. And mostly IPCC, Intergovernmental Panel on Climate Change, yeah, so have relied on this process-based integrated assessment model, also for not also to quantify mitigation scenarios. What could be different greenhouse gas mitigation pathways? Yeah, and then to explore like if there is a technological change, if there is a, let's say, carbon capture and storage, yeah, if there is a shift from fossil-based energy to renewable energy, what will happen? Yeah, how much greenhouse gas emission that we can reduce, and what does that means in terms of other socioeconomic parameters? So there are a lot of exercise that is done. Yeah, so here the idea is to give you more like exposure on these big models. Yeah, I'm a bit hesitant to call high resolution because most of these models are running on not at the global level or a global scale, but more as a regional scale. It consists of different world region, yeah, and only few may have like a country scale resolution, but still it's called like high resolution model because to run these models it takes a lot of time, yeah, and these are very complex models, yeah, and then most of these models runs in supercomputer. And if you want to go a bit deeper on this model, you can also look at that, yeah, and at some point maybe in your PhD or later on, yeah, you can also think about working in one of those modeling groups. Yeah. across the world so far. Yeah, so there are these few high teams. This ASEAN integrated model, which is based in Japan. Yeah, there is this climate change assessment model, which is more like a shared model between PNNL. Yeah, I think PNNL is, it's, no, I don't know where it is based on, but it seems like it's based on the United States. Now there is one in integrated global system model based on Cambridge, collaboration with also with MIT. Yeah, there is IMAGE model, which is also this integrated model to assess the global environment, which is based on Netherlands Environmental Agency, which is one of the powerful tool. There is MESSES model, which is like a model for energy supply strategy alternatives and their general environmental impact, which is mainly based on International Institute for Advanced System Analysis in Austria. At Potsdam Institute, in my institute, we do have like a REMIND model, which is about energy, but we also have other model called MAGPIE, which is more about agriculture. So and there is also this REMIND MAGPIE combination. So we see that there are so many models here, yeah, and some of this feature of this model, like energy, food, carbon, land use, these are also let's say key targets or the key issues that are also mentioned in Sustainable Development Goals. And that's why colleagues also try to explore how SDGs could be represented in integrated assessment models. So or how representative are Sustainable Development Goals in these integrated assessment models. When we look at integrated assessment models, we have to understand that this integrated assessment model has its own history. These are mainly developed from climate change perspective, yeah, and that's why what we can see here is that that if you look at this bar, we can see that some of the features are highly let's say we can map it's representative here. It's the one is about energy, because these are more like a energy system model, yeah, and then we can also see the climate action. Yeah, we can also see, if I can read it correctly, it's about what is this? It's, for me it's a bit hard to read. So it should be about economy, your GDP, and then there are also some of the goals which are not there. So it's hardly representative. And if you look at this number of icons here, I don't think there are 17 icons here. So currently all the integrated assessment, most of the integrated assessment model represents some of the SDGs, but not all. And what we can also see here is that when we look at, let's say, SDG interactions, because since these are more like a process-based model, it's quite easy to see how things are interacting. But the problem here is that in terms of SDG interactions, we can see that some of the interactions are there, but we also see a lot of gray. Let's say here the grayish color here, and this shows that currently integrated assessment model are not able to let's say to represent all the SDG interactions. But the good news here is like some of those SDG interactions can be represented or can be mapped on those integrated assessment models. And then we can see here that this when we look at this literature that is based on integrated assessment models, what we can see here is that SDG 13, we can see a lot of interlinkages, but like water, SDG 13 in terms of climate is there, some part land is there. There is a lot of things also with economic part is there. Partly there is also this food energy aspect is there. Food, energy, water thing is there. Because this water, energy, food nexus are also the thing, or the simulations that are widely done by some of these models, and also a lot of publications are there. But we can see that there is also a lot of gaps in current integrated assessment model in terms of SDGs. However, there are groups that are pushing forward this research, and what they are trying to do is that they are trying to move forward in terms of using or integrated assessment model, also in terms of sustainable development. Because integrated assessment model has provided a lot of insight in climate change negotiation, in terms of climate change, in terms of let's say in terms of informing IPCC, and also UNFCCC processes. And here one of the proposal now is that, like when you talk about sustainable development, so there should be also some sort of like a quantitative goal seeking is needed, scenario analysis is needed, and when you look at SDGs, now all the targets are not could not be quantified now, and sometimes these are really very vague now, and that's why there was this proposal to define this sustainable development target space now, which is mainly defining these 36 targets, which could be modeled using this integrated assessment models, and these are mainly based on SDGs, existing multilateral agreement, and literature and expert assessment. If you want to know a bit more about what are these targets, you can have a look at this paper from Detlef, which is really nice, and it's provide a framework for modeling sustainable development, and it shows that modeling communities are going a step further from looking at climate scenarios to more like a sustainable development scenarios. And then I also mentioned this term, like let's call like RCPs, SSPs, represented concentration pathways, which is about greenhouse gas concentration in atmosphere, shared socioeconomic pathways, which is more about socioeconomic development, and then there is ongoing discussion now, not to talk about shared socioeconomic pathways only, but also talk about sustainable development pathways. So this is one of the discussion that's going on, mainly with this World in 2020, the World in 2050 initiatives now, where also a lot of people are involved, prominent people are involved, including Jeffrey Sachs, Johan Rockström, and also other colleagues in Dick Messner, and other colleagues also in YASA there. So one can also have a look on this, so which talk about this transformation to achieve the sustainable development goal, and here the key message is that there could be we need to explore this pathways for sustainable development, and they try to talk about 6 transformation in terms for achieving sustainable development, and they started with here the paper here Jeffrey Sachs is published, I guess, in Nature Sustainability. It included also in the reading material, and this is more like a gist of this report, saying that in terms of sustainable development, one need to think about first transforming or ensuring education for all, gender equality or issues, and then also to address the issue of inequalities, and then the second transformation is mentioned about this health, well-being, and demography. There is a big prominent topic about energy decarbonization, sustainable energy, circularity and decoupling is under one here now. So, and then we do have this food, land, and also ocean. It's andro-powered cities, sustainable cities and community is andro-transformation areas, and then also with the emerging of this digitalization, so one also need to think about this digital revolution, digital revolution in terms of digitalization, and also this artificial intelligence and so on, as one of the key component about for sustainable transformation, and along this sustainable transformation, one can think about sustainable development pathways. The question is like how we can achieve the 2030 or long-term sustainability agenda, and what could be the pathways to achieve them. And in the modeling communities, this is also one of the ongoing discussions on how to derive these pathways. And this is one of the example here of those pathways analysis, yeah, where colleagues try to identify climate policies, yeah, and try to link that with different sustainable development goals. And one of the key messages here is that ambitious climate policies, as well as economic development and technology, and less resource intensive lifestyle are crucial element for sustainable developments, but only talking about them is insufficient. Yeah, there are other factors like SDG financing and all other things are discussed here. Yeah, and here we can see these different lines. Yeah, and these different lines represent, let's say, different sustainable development pathways. Yeah? So here we see this SDP 1.56. 1.5C, which is related to this blue line, yeah, and one can look at these different pathways using one of those integrated assessment model. If I remember correctly, this study might have been done using MAGPIE remind combination, and this is the study that is carried out at PIG. Yeah, so this is more like giving an overview on there are different models. So one can start with conceptual models and then go further to mathematical models and combining these mathematical models into system dynamic models, yeah, or various system models, which is more looking at interlinkages, which might not be dynamic now. And then one can also think about more, let's say, process-based models now, which is in a very full-fledged, very sophisticated way. It could be integrated assessment model, and increasingly it is also being used to discuss about sustainable developments. Yeah. These models are basically for every model there is this validation and calibration period is crucial, is essential part. No? For some model like there is a very long history, or it takes a lot of time to build this model, yeah, and sometimes individual component of these models are validated and tested, and these are validated and tested based on historical data set. Yeah, certain part of the more time period is used to validate the model, yeah, and then to calibrate the model, yeah, in terms of model parameter and so on, yeah, and certain time of the historical period is used to let's say validate the model, and based on this calibration and validation, the model is developed, yeah, and model is calibrated and validated. It is used for future projection. Yeah, so basically the calibration and the validation are done for the historical time period. It is not done for the future, because for future scenario it's very hard to calibrate and validate it now. And then also these model are also compared with each other. There are different models, and then people also do this model ensemble in studies, so that when we talk about future scenario with similar assumption, because of this different let's say ingredients of the model, they may have different range of projection. Yeah, and what modelers do is like often they also use ensemble results, yeah, to say something about the range of the result, because there are some strength of some models would have strength on one dimension but weakness on the other, and that's why increasingly it is encouraged to use model ensemble. So one can get such relation between energy and GDP and then make a projection for future energy demand. But in terms of, let's say, sustainable transformation, some of those historical trends need to be bent. So like we are talking about bending the curve of biodiversity loss. Yeah, in some cases we are talking about degrowth. Yeah, for example, whenever we plot let's say food demand with GDP, we see some sort of like curve like this, and in some cases we need to bend this curve using, let's say, for example, in terms of we talked about this Kuznets curve. And one of the limitation in my point of view is that some of those models, which are mainly based on historical relationship, would not be able to capture the future relationship that we need to do in terms of transformation. Yeah, because transformation is not to continue as we are doing in the past, but to do the things differently. And when we need to do things differently, how how is it possible to capture this thing in the model? And sometimes this means that the equations, the mathematical equations that are used need to be changed to reflect those future transformation. And I would say like this could be one of the key limitation when we are talking about the model. And the question is like, how can we make our model possible to capture those relationships? So normally the exercise of these models are definitely to make some prediction for the future. I would not call it prediction. It's more like a projection for the future across different scenario. So what happens if there is something? And this sort of prediction could be projection are somewhat. If you look at this limit of growth, I talk about this paper in I think in the first class, and they use like a very simple model at the global scale. And if you look at these models, some of those things are still valid. So we can see that the projections are right. So when we use this very basic biophysical law and then try to make a prediction in a larger scale, yes, we can see that now. But when we talk about this very regional specific, very local specific phenomena, then one need to also build a model for very local location specific phenomena to understand more processes, and things will be more challenges. And one of the reason to build this model is to make a projection in the future based on different scenarios, and then to inform policymakers about, like, if you take this scenario, we are going into this path. Now if you take the scenario of RCP 8.5, then we are going to we are having like a very hot climate now. A lot of climate impact will be there. Now if you go for RCP 2.6, then it will be there will be less global warming and so on. So this is the whole purpose. And as I mentioned earlier, all models are in a way wrong, because it's not like an exact prediction, but some are useful, if it is used in a wise way to make informed decision to change the thing. And then to build this sort of model, there is a lot of exercise that is done, and all these small models or big models has small components which has been added across the time, and each component have been tested, validated, calibrated and then developed further across time. And there is always uncertainty involved there. That's why there is a lot of scenario testing is done. There is a lot of comparisons is done here. And as I mentioned, this is one of the things that could be used for decision making or support decision making. But there is also other thing when you talk about decision making that is used quite a lot, or this term used by a lot, like a decision, like a tool. So my question for you would be like, what is a tool? So in a way, like, tool could be anything. So if you want to nail if you want to put a nail, then a hammer could be a tool, or a stone could be a tool. So or we are using mouse and all this thing. This could be also a tool. So anything could be a tool here. And in the context of SDGs, what we are talking is that we are talking about meeting the SDGs. And then whatever that support to meet the SDGs, in a more user-friendly way, could be a tool here. And here I would like to draw your attention to few tools that are used in terms of achieving SDGs. And in general, these tools could be classified into, let's say, 3 different types. One would be more like a SDG monitoring tool, or SDG visualization tools. So one can look at this tool and then see where the progress are made. And one of this tool could be, let's say, Atlas of Sustainable Development Goals. Mainly, this is coming from World Bank, where they are plotting the data from their World Development Indicators and try to show that where the countries are achieving. So it could be the visualization for only one country or all the countries here. So I took here example of urban rural divide in electricity access, where each dot is a country, and we can see that I don't know which year is this, but it should be the recent year for 20. So what we can see here is that there is a lot of divide between rural and urban area, and one can take on the country they are interested on, and then try to see okay, what is the situation in the country, yeah, and why this sort of tool is important, because you can make a plot like this and then bring to your politician or a policymaker, saying that, look, even though in general we see that we have good access to electricity, however, there is a lot of rural-urban divide, and there is a lot of rural population that is lagging the access to clean electricity. Yeah, and we can see some graph here where the divide is quite larger, and others it less. Now, so this is one sort of tool that could be used, or this Atlas, Sustainable Development Atlas from World Bank is one of such tools, which is more like a SDG monitoring tool, which could be used to visualize the indicators or data of the indicators, and then try to see where one is there, or how far the country are. Here we compare the countries, but also one can also see the country progress across time. If you click on certain countries, you can, whenever you have time and interest, you can look at those links and then make some do play around this data set and try to see things. Yeah, and as a figure can explain a lot of things. Yeah, simplified figure like this also will help to generate awareness and also inform the urgency for certain things. Yeah, and then what we did is, like, we talk about sustainable development report. Yeah, this is coming from Sustainable Development Solution Network. Yeah, and I guess by now you may have all of you may have look at this link. Yeah, and play around. Yeah, also for your assignment. Yeah, this is also one of the tools, because that's the whole concept about Sustainable Development Index and Sustainable Development Dashboard, to show a country like where they stand. Yeah, and I pick up this example from Myanmar to show like how they are making progress in terms of SDG index. Yeah, and one can also go a bit deeper to look at the SDG dashboard to show that whether a country is. And if you remember, there was this arrow, green arrow, and if I remember correctly, red arrow, yeah, red color box, to show whether they are in the right trend or not to achieve SDGs, or whether there is some regression. Yeah, so this is another example of such tool which is out there and which is quite popular. Yeah, so maybe you already have played with that. And there is also this thing called SDG tracker. So have you heard about this tracker thing? There are different trackers. So there is also this climate action tracker, yeah, NDCs tracker, yeah. So in climate community, there is a group of independent, I would say, let's say NGOs or communities who are developing this tool called trackers, so that one can track the progress made. And there is also this thing called SDG tracker. And mainly this SDG tracker is looking at SDG database, or mainly the plots that are made in World in data. So maybe you have heard or seen the maps plotted in World in data, which is also a tool which provides visualization of different data set. Yeah, and then provide some sort of like information in terms of awareness raising and so on. Yeah, and SDG tracker try to link the data from world in data, or the visualizers from world in data, and then try to tag with the SDGs. Yeah, to provide information on where we stand on SDGs. Yeah? So for example, this is one example. Yeah, and you can see here the map is coming from World in data, and then they try to, in terms of SDG tracker, they try to link this thing with SDG indicator. For example, here, access to clean fuel for cooking, and this is SDG indicator 7.1.2. And then here, what one can do is, like, there is also a video. Yeah, so one can click on this chart and then see how country make progress on this indicator from 1990 to 2020. Yeah, so this is one of the way to see or visualize the SDG progress. Yeah, which is also one of the monitoring tool here. Yeah, so when you have time, you can also play around with this tool, and in some cases, yeah, you can also see how these things are plotted. So, but when you talk about achieving SDGs, it's not enough to talk about, let's say, visualization tool. which shows how much progress is made, because one of the crucial thing is to talk about SDG synergies and trade-offs. And there is also a tool called SDG Synergy tool, which is developed by Stockholm Environment Institutes, and this is mainly a tool that will help stakeholders or people to apply this tool to understand SDG synergies and trade-offs. They can use this tool to explore SDG synergies and trade-off by themselves. And this is an example. You have seen this scale again and again now, and basically SCI is one of the institute behind developing this scale. That's why they are also using this 7 scale approach. And with the stakeholder consultation, what they can do is that, or one can create this sort of matrix for SDG interactions, and then go a bit detail from developing SDG interaction matrix to SDG network analysis. And one can use this tool for that processes. So if you are interested to do some sort of a study like that, you can also look at this matrix and then look at this SDG synergy tool and then apply that for your study. There is also other tool called SDG impact assessment tool, to understand what is the impact of certain thing on SDGs. This is jointly developed by SDS in Northern Europe, and then you can also see here Chalmers University is there, University of Gothenburg is there, mainly coming from Sweden, where one can use this 5-step approach to conduct SDG assessment, and this SDG assessment could be done for different strategies or for different things. This is not much about SDG interlinkages, but it's more like interlinkages of certain thing with SDGs. And one can look at, or they provide this information on direct positive to direct negative interlinkages, and then one can assess this for certain strategy. So you can also have a closer look if you are interested on that. Going a step further, there is also this SSA interlinkages analysis and visualization tool that is developed by IGES, Institute for Global Environmental, I think, Sustainability, IGES in Japan. So I forgot the full name here. And here they also provide a tool to visualize SDG interactions. And I guess they have more than 20 countries available there, and mainly they use mixed method, combining qualitative approach to quantitative approach, to create SDG synergies and trade-off network, and then they provide this as a visualization tool to understand SDG synergies and trade-off, for different countries. Here is an example, and it's quite clear here, so how the network is differ when you compare two countries like Nepal and Thailand. So one can also do comparison between different let's say different countries, or one can also zoom into certain goals and have a look on that. So there are tools like this, if you want to know a bit more about SDG interactions, and these sort of tools are also quite powerful to provide clear messages for policymakers. Now, for example, here we can see that the SDG 1 is quite interlinked with most of the SDGs or most of the other targets. So that shows that, okay, we need to do something with poverty. And we discussed also in SDG interlinkages class, saying that poverty could be one of the target, or SDG 1 could be one of the goals that could have a lot of synergistic relationship with other goals. And then the SDGs are not taken up only by let's say science and policy, but also companies are also talking or using SDGs as let's say for showing them how sustainable are they, to assess their sustainability. And there are a lot of other tools available for company to measure how sustainable they are, depending upon their strategies. After your graduation, if you are working in certain companies, you might be using such tool, and this is let's say SDG Compass is one of one of those tool where they started with providing understanding of SDGs, and then there's a whole circle here, yeah, or procedure here, in a way to provide overview on how company is performing in terms of sustainable development goals. Yeah, there is also another tool called Sustain 2030 tool, so which is also which provide also the information on SDG interlinkages and interactions, and this sort of tool is also guided to private sector decision maker. Yeah, so they can play around with their company's data set and then try to figure out how these tools are working. Yeah. And there is also the monitoring tool for company to show like how these companies are performing in terms of sustainability index. Yeah, and then they can pair their activities into sustainable development. So when you talk about sustainable development, so these tools also shows that sustainable development is not only the agenda of, let's say, development community or government or NGOs and INGOs, but also this is increasingly becoming a part of company as well. So they are also evaluating themselves across how they contribute to across 17 sustainable development goals. And then there are also other tools, yeah, which are there, but they may not call themselves as a SDG tool. I bring here one example here of European calculator. Yeah, this is another way of looking at let's say this is not a this is another way of looking at interlinkages between different societal and human systems. Yeah, the calculator approach. Yeah, so there is this integrated assessment models, but there are also this calculator approach, and here I bring this example of European calculator, and here you in terms of circles, yeah, you see these 4 different circles, and one can choose the ambition among the circle and try to run this model to show that what happens if, so for example, in terms of diet, if the ambitious diet would be, let's say, to be more like a vegetarian diet. Yeah? So what happens if everyone in Europe become a vegetarian? Yeah, what does that mean in terms of whole system? Yeah, so this is more like a calculator based approach. Yeah, and one can use this calculator based approach also to make some decisions, and one can also see interlinkages between different systems here. Yeah, even though it's not explicitly tagged as SDG tool. And you can see here there is emission. I show here the figure for greenhouse gas emission, but there are also graphs coming up for energy, transport, building, industry, land use, and all other part. And whenever there are some sort of like conflicting things coming up, you see already here, let's say, exclamation mark with water, material, climate. Yeah, so it provides some sort of like a flag saying that there are some trade-offs, there are some conflicts going on if you choose these sort of parameters here.